Hi there, Year 8. So today we're going to be looking at reflections. We're also going to be looking at reflections next lesson as well. So we've got 2 lessons on this. We've got a lovely practical to do. You don't have to do the practical today. So if you can't get the equipment today, that's fine. You can do it on the next lesson. So we've got a few days to do this in. Okay, and we're going to be looking at what a reflection is and how it works. So the first thing I want you to do, your do it now task, okay, go and take a look at someone else in the mirror. So stand next to someone else and take a look at them. Do they look different? Do they look how you expect them to look? Okay, so just pause the video and go do it now and just tell me how they look different. Have you done it? Go and do it. Okay, welcome back for those of you who have done it. So hopefully you'll have noticed that the image in the mirror, and I'm filming this next to a mirror, so hopefully you can see me and a mirror. Okay, so hopefully what you can see is there's a few differences between me and the mirror me. Okay, we're the same way up, which is pretty useful because, you know, being upside down in a mirror would not be that great. But if I look at it, my fringe, which I seem to think is on the left side of me, in the mirror, it's on the right side of me. So it looks a little bit different. Okay, that's the main difference that I can see is my hair parting, but obviously my face isn't perfectly symmetrical, and that's really shown up when you look at me here and me in the mirror, because it just looks slightly off. No faces are symmetrical. So seeing someone in a mirror, everything looks just that little bit off. Okay, so what we're going to look at is how to draw a diagram. Before we do that, a couple of things I want to say. So because it's been flipped and right is left and left is right, that is what's called a lateral inversion. Okay, lateral inversion, and it just means it's been flipped right to left and left to right. So everything has been switched over. Okay, so it's been laterally inverted. I do quite like that phrase. And also, so I'm looking in the mirror and I can see my bookshelf over there. So can I reach into the mirror and pick up a book? Hopefully you've all just said no there, because those of you who think you can, I am slightly worried now. Okay. So yeah, I can't do that. What's in the mirror isn't real. It's reflecting something real, but I can't reach in and touch it. And so we say it is virtual. Okay, and you guys all know what a virtual world is, and the mirror is showing me a virtual world. It isn't real. Okay, so let's go see how we can draw this. Okay, so you will need to copy this diagram. It's up to you if you copy it now, or if you copy it when I've finished talking, or if you copy it while I'm talking. That would be a bit cunning, wouldn't it? Okay, so what we've got at the bottom here in blue is a plain mirror. Please note the spelling. Plain does not mean unadorned, okay? It's meaning plain, as in it is in one plane. It's the mathematical use of the word plane. So it's in the X plane, or it's in the Y plane, or the Z plane, okay? So in this case, it's just a straight mirror, okay? Normal mirror, straight mirror, and it's called a plane mirror. Okay, and at 90 degrees to our mirror, we've got something that you can't normally see. Okay, it is an imaginary line, and it is imaginary, and we call it after something else imaginary, which is the normal. Okay, so if anyone asks you about normal, you now know what it is. The normal is an imaginary line in physics, in science. Okay, so here we go. We have got our plane mirror, and at 90 degrees to our plane mirror, we have got an imaginary line called the normal. And what happens is we are going to shine a light at a mirror, and I'm going to show you the setup for this in a minute, okay, because we're going to plan the experiment. We are going to get a light source here. That's our light source. And our light source is going to be a thin ray of light which goes down into our plane mirror, and it's going to go at an angle. You can shine it along the normal and see what happens, or you can do it at an angle to the normal. Okay, and this angle here, the angle to the normal, and we measure it against the normal, not against the mirror. So our incident ray goes into the mirror, and our angle of incidence is between the normal, our imaginary line, and our incident ray. Okay, and what happens is it looks like our ray keeps on going into the mirror. Okay, that's what it looks like, but it doesn't. That's a virtual image. It's not real. What happens is it's reflected, so it comes back up. And bizarrely enough, we call it the reflected ray. And if you notice, there are arrows here and here that show you the direction the light is travelling in. I did show you the arrows last lesson, so it's important that we draw on the way the light travels. Okay, this is called the reflected ray because it's the ray that has been reflected. So original, but it's easy to remember, isn't it? And the angle between the normal and the reflected ray here, that is the angle of reflection. Okay, so we've got an incident ray, an angle of incidence, reflected ray, an angle of reflection. You do need to know all of these terms, and you do need to write them down. So you'll need to pause the video and you will need to copy this diagram. Okay, and then I'm going to show you how to make it. You are going to need to write down the method, and you are going to need to tell me the variables. We can probably do the variables without showing you the practical, but it's a lot easier if I show you the practical and show you what I'm changing, and you can tell me how you're going to change it. Okay, so what I've got here is a little cardboard box that my son's sweeties come in, and I have cut 2 holes. I've put a nice big one at the back where I can fit a loo roll into. Okay, I do realise that science is a little bit heavy on the loo rolls this week. I feel like I'm in Blue Peter. And we've got a slit in the front, which is really small, just a couple of millimetres long. Okay, you can do it without the loo roll, but it's a little bit more difficult. So what we're going to do is I'm going to set it up so that we've got our cardboard tube here and our light beam coming out here, and I'm going to shine a torch through it. And I'm going to turn out the light so you can see what's happening better. Okay, back in a second. So what you can see is the light shining out of this slit here. And what I'm going to do is I'm going to just get my ruler and draw along it. Okay, now I'm going up to the edge of the table and I fold the paper over for where my plane mirror is, because my mirror, as you can see, is a little bit small and won't give me a very good result unless I'm putting it right on the edge of the table. Okay, so let's line that up again. And now I can see where it's being reflected from. So I can draw in my reflected ray without trying to not get my hand on it. Okay, and it's there and it's there. All right, and then what I do, I'll turn back on the light back in a second. Okay, so what I'm going to do is then I'm going to match this up. It doesn't matter that I've put my mirror away because I've logged where the line was. Okay, and I also know that 90 degrees to the table was where my mirror was, so I can draw on my normal. Okay, there we go. So what I did was I set up an angle of incidence. Okay, so what do you think my independent variable is? What did I choose? What can I change by moving my ray box around like that? That's right, I can change my angle of incidence, which means that that is the independent variable. Okay, so I'm going to measure my angle of incidence and I'm going to write it in a useful table that I have got at the top here. Then I'm going to measure my dependent variable. Okay, what's my dependent variable? Well, what changed when I changed my independent variable? the dependent variable depends on it, and it's the angle of reflection. Okay, and I've called them I and R because you will see that it's called I and R in physics textbooks. So then I get my protractor, I measure my angle of incidence, and it's coming out at 42. I've measured it properly. So my angle of incidence is 42 degrees. So just take a look at the table here, because you're going to need to draw one of these. Okay, and then I'm going to measure my angle of reflection. And then I'm going to do it again. Okay, so I'm going to do it more than once because I need an average. Okay, so let's